and welcome to class. In this video we will be studying about binomial expansions using Pascal's triangle. Now you might want to ask, what is a binomial expansion? Now in your mathematical computations you will find out that there are times when you would need to expand brackets that are raised to powers. It could be something like your a raised power a plus b raised power 2 in brackets, or it could even be a plus b raised to power 3, or it could be x plus y raised to power 5, as the case may be. Now notice that each of these expansions would require that you multiply whatever is in the bracket the number of times you have your power. So if you have a plus b raised to power 2, that would mean that you have to multiply a plus b into 2 places, and when you have, like in this case, x plus y in brackets raised to power 5, that would mean that you have to multiply it into 5 times 1, 2, 3, 4, 5. That is that. And sometimes it can be time consuming for you to multiply expressions like this, where you have to take your time and go after the one after the other. Alright, now but what we want to study today is a method, a means that can be employed in the expansions of these brackets, and one of them is using the method known as Pascal's triangle. Now Pascal's triangle has been in existence centuries ago, but it was brought to limelight by a man named Blaise Pascal. He was a mathematician, so he brought this to limelight. There had been people before him, hundreds of years before him, who has been studying this particular triangle. However, he brought it to limelight and made it, popularized it. That is why he took on his name, Pascal. His name is Blaise Pascal. So I want to look at what really is Pascal's triangle. Okay, I'm going to go straight into how that can be derived. Now, for you to get a Pascal triangle, I'm first of all going to show you how we derive that, and then the application, how they are used. So the first thing that you want to do is you start with a 1. So we're having a 1 here. Okay, let me shift a bit. So I have a 1 here. Now the next thing that you do, you want to place other ones by the side. Having done this, now your Pascal triangle will always start with a 1 and end with a 1. Then you have to add up every other thing that is in between. So for me to get the next level, level of numbers or digits, what I will need to do, I'll write my 1 as well. Then these two ones I have here, 1 plus 1, I'm going to add them together. So 1 plus 1, that will give me a 2. No more, nothing to add again. I'll also end with a 1. The next level, I'll start with a 1. 1 plus 2 here, that will give me a 3. This 2 plus a 1 here, that will give me another 3. Nothing else to add. I'll write my 1. The next level, I'll have a 1 again. I can add 1 plus 3, that will give me 4. 3 plus 3, that will give me 6. 3 plus 1, that will give me 4. Nothing again to add. I'll write my 1. The next one, I start with a 1 again. 1 plus 4, that gives me 5. 4 plus 6, that gives 10. 6 plus 4 again, that gives 10 as well. Then 4 plus 1, that gives 5. Nothing again to add. I'll write 1. If I want to get the next level to 6, I can also start 1. 1 plus 5, that gives 6. 5 plus 10, that gives 15. 10 plus 10, that gives 20. That gives us 20. 10 plus 5 again, that gives us 15. 5 plus 1, that gives us 6, and then 1. So you just get how it's working. So you can go on for as long as you want. So what I've done from 1 up to 6. I could go on and on and on and all that. You just have to take your time and understand what we're doing. Now the question becomes, how can I utilize this? Okay, I'm going to show how that can be done. Okay, let me just try to shift this a bit. Okay, so alright, so I have a Pascal triangle here drawn. Now all these levels that you have, okay, all these levels that we have, the one for 4 and the one for 6, 5 and all that, they are the coefficients, the binomial coefficients that you are to use to expand any given bracket. For example, when I have an expression to expand, say a plus b raised to the power 2. Okay, you can go ahead and expand this using the normal method of expansion, that is you multiply a plus b in bracket into two places and get your answer. Now, how can I use binomial or Pascal's triangle to expand something like this? Now, notice that the power is 2, and for that case, when I draw my Pascal's triangle, I will need the level for 2, and the level for 2 has the following coefficients 1, 2, and 1. We're going to use that. Now, one other thing that you need to note is that the rule for your Pascal triangle is that when you're using you're going to use the coefficients in your triangle, that's your 1, 2, and your 1, one after the other, one at a time. But whenever you're using the coefficients, what you want to make sure is that looking at your bracket, the first term in your bracket, in this case is a, and the second term in the bracket is a plus b. So the first term in the bracket will always decrease from the given power down till 0. I'll say that again. The first term in the bracket will decrease from the power, the given power, down to 0, while the second term in the bracket will increase from 0 until it gets to the given power. Let's practice and see how that would work out. So we want to expand a plus b raised to power 2 using a Pascal's triangle. What we want to do is I will take the first coefficient in the triangle for raised to power 2 for a power of 2, that is 1. So I'll write my 1, that is this one here. I'll write 1 times the dot product. That's this dot is not the decimal value, it is shows times, so you're multiplying. So that is 1 times, then what is my first term in the bracket? The first term in the bracket is a, so I'll write a. Okay, and remember that your first term will always start decreasing from the power, given power, which in this case is 2. So I'll have my 1 times a raised power, that is a raised power 2, which is the given power. Okay, then times my second term is b. Okay, so that's the b, the second term. So I'll write the b this time around, but remember that our b, the second term, will start increasing from 0. So I have my 1, I have this one gotten from the Pascal's triangle for 2. I have my first term a having the power 2, I have my second term b having 0 as power. Okay, the next thing I want to write, you write your plus, you go over to the next coefficient, the next coefficient in your triangle, which is in this case 2. So I'll need 2. I'll write my 2 this time around times, I'll go back to my triangle, my bracket. The first expression there is still 2, so I'll write, sorry, that's a. I'll write my a. Now remember that the first term will have to decrease from the power down to 0. So here it is 2, therefore decreasing, you have 1 now, that's a raised power 1 times my b second term. Remember, it's going to increase from 0, so if here is 0, that means my b will have to have 1 this time around. Having done that, the next thing you want to write again is your plus. You go back to your triangle, the next coefficient there is 1, that's the last of them. So I'll write my 1 times my first term is still a, so I'll write a. Now remember that the first term will always decrease from the highest power, the power 2, in this case 2, 1. The next power of a would be 0. that 0 times the b. Now the b is going to increase from 0 1. The next value of b is going to be 2. So having done this, what I will need to do is to simplify out. Okay, so let's simplify out. So I have here, considering this, considering here, I have 1 times a raised power 2 times b raised power 0. Now b raised power 0, you know it is 1, because anything raised to the power of 0 is 1. So what I have here is 1 times a raised power 2 times 1. And 1 times a raised power 2 is a raised power 2, then a raised power 2 times 1. So here we'll evaluate to a raised power 2 plus over to this one. What I have here is 2 times a raised power 1 times b raised power 1. A raised power 1 is a, b raised power 1 is b. So 2 times a times b, that will give us 2ab, okay, plus, then over here, this is our 1 times a raised power 0 times b raised power 2. Now remember that a raised power 0 or anything raised power 0 is 1. So what I have here is 1 times b raised power 2. 1 times 1 is 1. 1 times b raised power 2, that will give us b squared. And this is our answer. Now when you consider what you have done, if you had gone ahead to calculate it yourself using the normal expansion, that is a plus b into bracket a plus b, you would still get this answer that we have here. Alright, so you might think that it is taking time, but it is not. Let us consider a huge example. Now let's expand something that has a power of 5. Okay, now note that for our 5, anything that has a power of 5, we are going to use this coefficient values to expand that. So let's try to expand. Okay, so let me go to, so let's try to expand a plus b raised to the power of 5. Okay, or let me try minus so that I'll show you something. Raised power of 5. Okay, now you note that we need the coefficient. So when we draw a Pascal triangle, let me go ahead and quickly draw that again. So I have my 1 1 1, I have my 1 2 1, I have my 1 plus 2, that's 3, 2 plus 1, that's 3, I have my 1, I have a 1 again, 1 plus 3, that's 4, 3 plus 3, that's 6, 3 plus 1, that's 4, I have a 1, then I have again 1 plus 4, that's 5, 4 plus 6, that's 10, 6 plus 4, that's 10, 4 plus 1, that's 5, and then 1. So this is what I need. Alright, this is what I need for my expansion. So I do not need the other one. So I can even go ahead, if I so wish, I can go ahead and clean up all this, knowing that what I need is simply this. So let me just keep that here so we can always reference that. Okay, so we need 1 5 10 10 5 1 for this expansion. So let's see how this will work out. Now remember that whenever you take each of the coefficients, you are going to utilize your first term and the second term. The first term will decrease from the given power down to 0, while the second term will increase from 0 to the given power. So let's take the first coefficient here, that is 1. So I have my 1 times, the first term is a raised to the power of 5, that's our given power, times the b. And now notice that our b is not just, second term is not just b, but minus b. So you want to put that in your brackets. So that's minus b raised to the power 0. So we have a minus b raised to the power 0. Okay. So the next coefficient, we'll have our plus again. The next coefficient is 5. Alright, so I'll take 5 times our first term is a, that's a raised to the power, Now remember, it's going to decrease from the power 5 down to 0. So the next, if here is 5, the next will be 4. So we'll have 4. We'll have 4 times b. So we'll have times the b. So we'll have times b. So we'll have the second term, which is minus b. Okay, this is taking a while. So have a minus b. Now the next value will be 1. That's the power, because it's increasing from 0 up to 5. Okay, then we'll have again plus. We'll have a plus. Alright, the next coefficient term is 10. That's 10 we'll have here. So we'll take our 10. The first term in the bracket is a, so we'll have 10 times a raised to power, that will be 3 because we are decreasing for the first time, times the second time is minus b raised to power, we are increasing, so 1 from 1, the next will be 2 plus, okay, the next coefficient is 10 as well, so we have a 10 times a raised to power, a is decreasing from 3, it's going to be 2 now, times minus b, from minus b is increasing, so from 2 the next value is going to be 3, so we have a 3, alright, plus the next value of the coefficient, that is 5, so we have a 5 times our first term in the bracket, that is a, remember it's decreasing from 2, it's going to be 1 this time around, times our second term, which is b minus b raised to power, the next is going to be 4, that's to the power of 4, alright, plus the final value of our coefficient, which is 1 here, so we'll take our 1 times our first term in the bracket, which is a raised to power 0 now, so we'll have the power of 0 times, that is times the second term, which is minus b raised to power 5. So our a has decreased from 5, so we'll have our a 5, 4, 3, 2, 1 and 0, whereas our b has gone from 0 to 1 to 2 to 3, 4 and 5. So at any given time you want to make sure that this tallies, this pans out, okay, so from 0 until you decrease to the power, from the power until you decrease to 0, the first time decreasing from the power to 0, while the second time increasing from 0 to the power. Now at this point what you want to do is to simplify what you have been given. So for us to simplify, we'll consider here, so what we have here is 1 times a raised to power 5 times minus b raised to power 0, but of course anything raised to power 0 is 1, so what we have here, there is 1 times a raised to power 5 times 1, and that will give us a raised to power 5. Alright, that's a raised to power 5. Oh, sorry about that. That's a raised to power 5. Okay, now considering the second one, now looking at our brackets, look at our bracket here, we have a minus b raised to power 1. Now minus b raised to power 1 will still give us minus b, and for that very reason, because our power here is odd, the minus sign here is going to affect the plus that we have here. So minus times plus is going to give us a minus. So what we're going to have now is a minus sign here, then 5 times a raised to power 4 times b, that will give us 5a raised to power 4b. You might want to take your time to understand how that works out. So what we're having is 5a raised to power 4b. Alright, okay, we'll consider the next one. Now minus b is squared, that is the power of 2, and minus times minus will still give us a plus. Therefore, the next sign that we're going to have is a plus. So we have a plus sign. Then simplifying, we have 10 times a raised by 3 times b raised by 2, and that will give us 10 a raised by 3 b raised by 2. Alright, over to the next one. Now when we consider the value of the minus b raised by 3, because our power is odd, minus b times minus b times minus b, that will give us minus b raised by 3. Therefore, the next sign is a minus there times the plus, that will give us a minus. So we're having a minus sign. 10 times a raised by 2 times b raised by 3, that will give us 10 a squared b raised by 3. You see a pattern that when the power of the negative term is even, we have a plus. So here we have 0, it's plus. Here we have 2, it is plus. But when the power of the negative term is odd, we are having a minus. In this case of 1 and for 3, we have had minus signs. The next is to consider this. Now the power of the negative term, that is a minus b raised to power 4, is 4. That is an even number. So minus b times minus b times minus b times minus b, that will give us plus b raised to power 4. So altogether what we have here is going to give us 5. So that we're having plus 5a, because a raised to power 1 is a, so we have 5a, then b raised to power 4. Alright, b raised to power 4. Now considering the last there, we have the negative term is minus b raised to power 5, and because the power is odd, that means that minus b times minus b, that's times minus b times minus b times minus b, that will give us minus b raised to power 5, and minus times plus here will give us a minus, so we're having a minus. Now simplifying the terms we have here, a raised to power 0, here that's 1, so we're having 1 times b raised to power 5, and that will give us b raised to power 5. And this is what you get when you expand this bracket. Now you might want to go ahead and try it out. Try to expand this using the conventional method, that is your a minus b into bracket a minus b into bracket a minus b, that into 5 places, and see how long it's going to take you for it, and eventually you're going to arrive at this answer. Okay, so this is like an introduction on what this is all about, the Pascal's triangle. There are other problems that we'll need to solve, which will be in a future video, but for now I wanted to introduce us to what this is, binomial expansions using Pascal's triangle. Do not forget how we can derive this triangle. Okay, it is easy to get. Take your time, make sure you always start with a 1 and end with a 1, and then follow the examples. Try to understand what we are doing. After that, now try out the following assignments to test your knowledge, and if there is any question or issue, you can reach out to me and let me know how I can be of help. So try this yourself. So let me give you some assignments to try out. Okay, so try using Pascal's triangle to expand the following. So I have here, let me say x plus y raised to the power 4 to, let's say, a minus b raised to the power 6, and okay, let's go up a bit, let's say raised to the power, okay, 6 is okay, 6 is still okay, so use 6. And the last one, please try this, a plus b raised to the power 8. Okay, now I'm giving you huge values so that you can be able to work it out for a while, and that will kind of test your resolve and help you to master the concept very well. So in the future video, we're going to look at other ways, other expansions that we can open up or expand using this concept of Pascal's triangle, and that will help us in our lesson. So on to the next class. Please make sure you tried giving assignments and follow the lessons. You can watch the video for as long as you want to make sure that you are up to speed with what you are expected to do. So I'll see you in the next class. Stay safe. Bye.